Okay, I would like to welcome you all to our first webinar of the ENBIS COVID-19 webinar series planned for April 2020. Through this series of webinars, we would like to bring together the researchers to provide a platform to discuss and share recent findings with respect to modeling, predicting, and monitoring of the effects of the pandemic to the society, industry, and business. Today, we will host Professor Ron Kenett. Please note that we have another webinar planned for tomorrow, the same time by Professor Mark Laville on modeling some COVID-19 data. Next Wednesday, again the same time, we will also host two other webinars. CAPS Monitoring COVID-19 Contagion by Professor Paula Gudigiu and Market Risk, Connectedness and Turbulence, a comparison of the 21st century financial crisis by Professor Daniel Hallegby. Please also note that we are having some web service problems these days, actually since yesterday, and we are hoping to solve the problem soon. And if not, you can also register for these webinars. Let me give you some information about how I will conduct the webinar. I would like to kindly ask you to mute your microphones during the presentation. I can also do that. If you have any questions, please use the chat box to me. I'm Murat Testik, your questions. Please also note that you will also have an opportunity at the end of the presentation to ask questions to our presenter. Meanwhile, during the talk, you can ask the questions from the chat box to me, and I can directly ask the question to the speaker. I would also like to inform you that the webinar will be recorded and it will be shared through different media channels. If you have any objections to this, please let me know. If you would like to access this webinar at another time, and if you would like to share this information with your colleagues, please note that it will be uploaded to our media center in a couple of weeks. As the presentation is over, a link to a feedback form will also be sent to you. If you have any comments or suggestions for us to improve our webinars, please let us know through this feedback form. Now, I don't want to take too much of your time. It's my great pleasure to introduce Professor Ron Kenett. Ron is the chairman of the KPA Group and senior research fellow at the Samuel Newman Institute, Israel. He's the past president of Israel Statistical Association and of the European Network for Business and Industrial Statistics. Ron authored and co-authored over 250 papers and 14 books on topics ranging from industrial statistics, data science, biostatistics, customer surveys, multivariate quality control, risk management, and statistical methods in healthcare. He held academic positions at the University of Wisconsin-Madison, the State University of New York, Binghamton, Bell Laboratories in New Jersey, and the University of Turin in Italy. He was awarded the 2013 Greenfield Medal by the Royal Statistical Society in recognition for excellence in contributions to the applications of statistics, and the 2018 George Box Medal by the European Network for Business and Industrial Statistics for outstanding contributions to the application of statistical methods in business and industry. He is founder and member of the board of several startup companies. Welcome, Ron. The words are now yours.
Okay, so I guess we can begin. I must say, 20 years ago, when ENBIS started, we had the vision of being a web-based society, but no one expected that to be a web-based society in 2020 is what it looks like these days. So in a sense, we thought of being a web-based society, but not to the extent that this is now. The other thing is that we wanted to make sure that when we meet and discuss statistics, we have fun. So my goal in this webinar is to use the web-based platform that ENBIS provides, but also to try and make it entertaining for everyone. Okay, so the talk is titled "Analytics in Industry," and the last few slides are listed as COVID-19 implications. So when we talk about Industry 4.0, so when we talk about Industry 4.0, what we have in mind is some kind of high-tech industrial plant. You can see the employees, the workers are all dressed up, and this is not a picture from the COVID-19 era. This is pre-COVID era. So this is what you might have in mind. The other thing that you have in mind is called twinning, and the plant that we see on the top right here has a twin, a digital twin, which is sometimes called a surrogate model. We sometimes call these beta models simulators, emulators. The twins are basically allowing us to do experiments and optimization efforts, which are then deployed on the physical plant. So we have a twin to the real plant, to a physical plant. In doing this, we have three elements that sort of play they play a role in a synchronous way. The first element is the element of sensors and data collectors. We can collect now data on lots of things. These are technologies we did not have 20 years ago or 15 years ago. Then we also have flexibility in manufacturing. For example, the 3D printing applications allow you to make pieces with batches of size 1. So you can make unique pieces, and you can make many unique pieces, each one being different. This will not work, will not produce something useful without the analytics and the statistics and the data science contributions and the models that are generated through that. So when we talk about Industry 4, at least in my mind, it has three parts: the sensors, the data collectors, the manufacturing flexibility, and the analytics. The analytics is supporting planning, is supporting productivity, is supporting materials control, many aspects of what happens in the plant, and it can be broadly classified into four types. You have analytics that is used for monitoring. You have analytics that is used for diagnostics. In other words, when your control chart shows an out of control point, you have some analytics to help you identify why this happened. Then you have some prognostics that give you the implication. In other words, what we are seeing will have an effect immediately, or will have an effect in 3 months, and this has obviously impact on what we do with the information. The fourth category of analytics is based on what everybody is looking for, which is prescriptive. Tell me what to do. I'm monitoring the sensors, I'm getting some out of control signal, I can see why it happened, I have the implications. Give me recommendations on what should be done. Should I change the tool? Should I reset the robot? What are the recommendations? This is called prescriptive analytics. And I told you we're going to have fun, and we're going to use this game called Kahoot. And what you're going to use is your smartphone. Hopefully you have a smartphone. I suggest you use your smartphone. You could use your laptop as well, but I suggest you use your smartphone. On the smartphone, you're going to see with a game pin that I'm going to give you 4 answers, the red, blue, yellow, or green, to a question. And the question is this: what you see here are 5 pictures. They are called alternative conceptual representations of a concept that I talked about 5 minutes ago. And you base your evaluation on picture A. Please identify which of the 4 B, C, D, or E pictures have conceptually the same meaning as A. Okay, so I'm going to give you a few seconds for that. We're going to use the quiz. The quiz is based on getting you into kahoot.it, kahoot.it on your smartphone. After you get into kahoot.it on your smartphone, you wait for me 1 second. And what you're going to get is a PIN number, 5549325. The first 50 people who entered that will be able to answer. Nobody has entered yet. We have 2 players who entered, 3, 4, 5, 12, 16. Okay, it keeps growing. So here we go. Wow. We have 14 correct answers, 6 and 5 are other answers. And if we have the time, we could discuss what are the reasons behind the other answers. But the idea is that this is an example of monitoring, as this healthcare person is also doing. So we have 2 different options, alternative representations of what is called monitoring. Now, in generating information, I've talked several times about this idea of information quality. We have a goal. So if we do monitoring, it's because we have a goal for monitoring. We have data. We have an analysis method, and we have some utility which tells us whether the analysis we did is good or poor. And we have identified 8 dimensions to evaluate that. And the idea of information quality is that you review your analysis. We're going to have another quiz, so hold on. Don't worry if you missed the first one. And these are the 8 dimensions. The first one is, do we get through the sensors the right data resolution for our monitoring objectives? Do we have the right data structure for that? Are we doing proper data integration, etc., etc.? So a historical perspective of where I think we are now. Let me move Murat's picture. Is that we moved from product quality to process quality, to service quality, management quality, design quality, and information quality over the years. And the idea of specifications and inspection were in the 1800s already, maybe even before. The idea of control charts for process quality came up in the 1900s. Then we had the ideas of, for example, Deming and Juran on process improvement. Taguchi showed up and taught us about robust design. And I think that now, in this age, we should be considering Industry 4 applications and information quality. So I think that's a natural evolution. The people behind this evolution, I will mention in a second. In the product quality era, we were using acceptance sampling. Okay, this is the example of the guild of cloth manufacturers. They were testing the cloth and they were putting a sign on the cloth. Then we moved to process control with the idea that we want to manage over control and under control. And in the management quality approach, the trilogy of Juran talked about control, design, and improvement. So what we do with data has changed over time. And the US attributes Eli Whitney as the inventor of specifications in the 1800s. Shewhart was definitely the person behind the control charts. Deming and Juran, I mentioned. The box, design quality, and Taguchi are the key contributors to these topics. So if you look at industrial statistics, this is a book this is the second edition of 2014 to 2014. It has chapters on acceptance sampling, process control, design of experience, and reliability. I think we are moving to information quality, which is a broader scope, a wider scope approach to data and analytics. And it links to Industry 4 and other and healthcare. So here we go to quiz number 2. Okay, so given what I just said, now you see 5 pictures. Hopefully you got the idea. Let me show you again the pictures. 5 pictures. Which of the pictures are like A? And we go for quiz number 2. So now you can be faster. Again, you're going to see a pin number. I think we had 23 participants before. Let's see what happens now. 20 seconds. The first 50 get a chance to contribute to this statistics. 435-915. Okay, no one. 1, 2, 9. 16. Oh, okay. Oh, no. We're moving up. Okay, so we have more participants. That's good. So here we go. Okay, now we have everyone on the scale. 14 people gave the right answer. which basically is because we have two images that represent inspection. Okay, here we have specifications, but the act of inspection is shown in these two pictures. So now I'm going to move into 3 examples of Industry 4 applications. One is based on a sensor, a fiber optics sensor, which is on strain measurement. Strain measurement is used to monitor deformation in structures due, for example, to changes in pressure or temperature. So the sensor is called fiber Bragg grating sensor, FBG, and it's used, as I mentioned before, for monitoring, diagnostic, prognostic, and prescriptive analytics. So you collect data from FBG sensors, and through models, you provide this type of analytics. So let me give you an example of 8 sensors. There are actually 7 sensors. Sensor 5 was defective, and they are positioned on different locations on the part, which is undergoing some pressure test. The black is the pressure, and what you see in the 7 paths is what happens to the strain on the model. Here we see the first sensor, FBG1, in 4 separate experiments, 1, 2, 3, and 4. Okay, you can see that there are 2 experiments that seem to provide the same deformation path, and 2 which are different. Here we have 3 more sensors. They match the pattern of the first one, and 3 more. So the 7 sensors seem to indicate similar paths. Here we see what happens to 3 of the stress that was applied to the part, pressure, temperature, and there are 2 temperature values, and there is one pressure. And we can now track what happens to the 7 factors on, for example, the 8 on the 7 sensors, and there is going to be a correlation structure. Because of the location of the sensors, we can account for the location of the sensors with what are called Toplitz blocks, which model the correlation structure that you see here. This is a Mahalanobis on the 7 sensors with reference to the first experiment, which was considered the healthy condition experiment. So everything is with respect to the first experiment. You see the 3 other experiments, what happened there. And here you see the t-square and the 3 factors that were changed and how differently they were changed over the 4 experiments. So we have data over time. We have pressure going up and down. We have temperature going up and down, or being stable, because these are smaller numbers. And you can see through the t-square, which is an overall view of the 7 sensors, what is going on. Another analysis, which is non-parametric, and this is the idea I got from Bianca in ENBIS in Nantes in 2018, is to use k-means clustering to model the path. JUMP is indicating to us that 10 clusters is optimal, and if we now compare the clusters frequency by experiment, you can see experiments 1 and 2 with cluster 3 being prevalent, and experiments 3 and 4 with cluster 9 being prevalent. And cluster 9, we have the details on what it consists of. The second case study is a piston simulator. It is based on software, so this is related to what we're talking about, twinning and emulators in Industry 4. Here it's an emulator of a piston. If you go to the website that is on the slide, and you will get copies of the slides if you're interested, you will be able to download a simulator, on the simulator, these are 7 factors that you can change, which affect the piston cycle time. And you can, for example, generate 50 samples. And one of the things you're going to be able to see is the control chart. So you see the numbers going up and down, and you have some statistics on that. Other applications that can be that this simulator can be used for is in running experimental design examples. So if you're teaching design of experiments, you can set up the factors with their limits. So the mass is between 30 and 60. And then in JUMP, you can go and design an experiment. For example, you can design a response surface central composite design. You load the factors. Here are the factors. What did I do? You load the factors. You choose the experiment. You run the design. And now we have 100 data points. What the app will do for you is to run the simulator as fed by these inputs. And now you have the Y inputs laid out. So now we also have Y, which represents the cycle time, and we can show how this simulator now can be modeled, and everything is integrated in a JUMP platform. So once you do that, you basically get people to run experiments, not just simplistic experiments. You can also do complex experiments and show them how to model the data and analyze it. So this was the second example. I'm moving to the third example. By the way, the code for this simulator is in JUMP, as I showed, but there is also an R version in the MyStat application you can download from CRAN. So this is used originally for teaching purposes. The third example is from suppliers of a company that makes these big printing machines. So this is a company in the Czech Republic, and they make this type of parts. This is a numerical control metalwork company. They are tested with CMM machines. These CMM machines are basically probing the measures that were obtained in the drilling that was done in the robots. And with a parser, you get data. This data is now turned into control charts for monitoring. There's a link here to some short video that talks about this type of system. We call it SPC Live. And if we add data, there's an action log data that is filled in by the operators. In other words, they also write up what they do and why they're doing it, as far as they can tell. And this is fed into a Bayesian network, which provides contextual information. For example, what part is made on what machine. And through there, we have some predictive analytics. So we can predict what would happen if this part was made on this machine or that machine. What would it do to, for example, triggering events? Here you have the 8 Western Electric rules. And what type of actions would be needed? Here you have prioritized actions. So the operation manager can, when he has an order, he can say, if I use this machine, this is what's going to happen to us. This is what I predict. If I use that machine, this is what's going to happen. Here I'm going to have a lot of tool issues. I'm going to have less tool issues, but maybe this machine is less used, and maybe we can pay the price of having these tooling issues because it's mostly idle, and maybe it's worth the effort. You can also do diagnostics. when a triggering event occurs, you can condition the Bayesian network to tell you what are the type of problems and causes that are the ones that are likely to have created this triggering event. So in the few minutes I have left, 5-6 minutes, some implications to COVID. So this is data. You have the link here. You can check it for yourselves. This is what was shown for New Jersey on April 14th. The governor of New Jersey came out with a statement: we are looking good, things are improving, we should celebrate. Now remember, we are talking about process control, and we have a lot of experience in the industry of numbers that go up and down, like the piston that I showed you. And let me show you April 15th. You ready? This is what happened on April 15th. And New Jersey was devastated. So we do see in the COVID-19 context lots of examples of over-control. People interpret the data without the proper glasses. Another paper that I thought was interesting is this BMJ paper, where they reviewed, these are clinicians, 31 predictive models, prognostic models. These are people who work in hospitals. They want to know where are we headed, do we have enough equipment, what is expected in terms of patients showing up, and what will be the symptoms and the conditions of these patients. Their conclusion after reviewing 31 models is I think, really bleak. As no clinical prediction can currently be recommended, and listen to this, clinicians will have to rely on the clinical acumen and shared experience of best practice for now. Which means forget about data, forget about statistics, forget about models. I think this is a terrible state of affairs to be in. Another thought on this, which is the next webinar speaker, is a very nice shiny application with change point detection. So in that application, here's the link. Okay.
Ron, sorry for that. I wanted to give some more information at this point. The developer of this shiny app will be our guest tomorrow. So the speaker is Marc Leville from France, and at the same time tomorrow he will give us some details about this model. And thank you for bringing that to our attention again, Ron.
Is the impact of social distancing. In the information quality framework, the 8th dimension is communication. We have very nice simulations which show the impact of social distancing. So the way this idea of social distancing is communicated now with simulations, I feel I think it's a nice example of how you communicate insights and information. So that was it, and I'm done. 40 minutes, yes. I will unshare.
Thank you, Ron. Sorry, I was trying to unmute my microphone, but I muted you at the same time. Sorry for that. I have one question. The question is, will the slides be shared? Will you share the slides?
Yeah, I mentioned that, yes.
Yes, okay. Thank you for that. Now, actually, the official webinar is over, but after this point, what we do is we will have a discussion, or if you have any questions, feel free to ask Ron about these. But like, since the webinars are planned for 40 minutes, 30 minutes, 40 minutes, the presentation part is over. So maybe we can continue with questions, answers. If you would like, you can directly write your question to the chat. If you would like, you can directly ask that to the speaker, Ron. So whichever you prefer. Now is your time. Any questions? So, Ron, thank you very much. And also, thank you very much for the other thing. Let me remind again, we will have one other seminar tomorrow. Ron already briefly introduced the modeling part of the COVID pandemic. So we will have a market reveal tomorrow. Next week, next Wednesday, we will have two consecutive webinars too. And one of them is going to be on monitoring. One of them is about the financial effects of the COVID pandemic. So I would like to thank you all again for attending the webinar. And we have 1 minute. We have one question. Can you share the link for the?
It will be. It will be listed on the slide. On the slides that I will share. It is down. Everything you can down. Not only that, but also additional things can be downloaded from the website of our book, Modern Industrial Statistics. So you can download both. But the R code you can download from the R code from CRAN. If you go to CRAN, you look at MyStat, Modern Industrial Statistics. It's there. The JUMP app is from the Wiley website of the book, and it is listed. It will be listed on the slide.
Ron, are you mentioning the Piston simulator? Because yes. Okay. Also, by the way, let me say it again. We will share this video is recorded, and we will share this recording in ENBIS Media Center. So you will also be able to access the video again to see that. And we have lots of thanks to you, Ron. So I will briefly mention that. We have, like, if you look at the chat screen, we have one shiny, some links provided. Thanks.
Yes, Emmanuel she's an expert in R. And if she recommends this, I would strongly recommend you look at it. She knows what she's talking about.
Okay, so we have lots of things for you. Okay, so we like if you have time, we would like to have you in tomorrow's webinar and next week's webinar. And if you have any ideas about future webinars, please let us know so that we can plan other webinars for you. Thank you very much for attending, and have a nice day, safe day. Bye.